finally, the last thing in this section is the coefficient of variation. So the coefficient of variation allows us to compare different data sets that may have different units or whose values are drastically different and see which one has more of a spread, right? More diversity to it. So to compare variation in different data sets, you can use standard deviation when the data sets use the same units of measure and have means that are about the same. So when you have data sets that are pretty similar, we can just compare the standard deviations and the means and get a pretty good estimate of how the data are similar and how they're different. But if you have totally different units or your means are really different, then it's not as easy to compare with the standard deviation. So what we use is the coefficient of variation instead. And it basically allows us to look at standard deviation as a percent instead of that just as regular standard deviation. So your coefficient of variation, which we always abbreviate as CV, describes the standard deviation, but as a percent of the mean. Okay, so we're taking it as a percent where the excuse me, the mean is sort of our base here. All right, so example 5, the table shows the population heights in inches and weights in pounds of the members of a basketball team. We want to find the coefficient of variation for the heights and the weights and then compare the results. So we're going to do each of them separately, right? So where you need to find the information for the height and also for the weights. Now notice in the formula, so for population and sample, they're actually the same formula, just the notation is different. So we're using sigma and mu for the standard deviation and the mean, and here we're using S and X bar for the standard deviation and mean, but the formulas are the same. So in each case, let's see, the table shows the population heights and weights for a basketball team. So if I have population data, then I'm looking for the mu and I'm looking for the sigma in each case before I can actually begin and find the coefficient of variation. So I'm going to get out my calculator here because I do not want to do this by hand anymore. So I just have my calculator app, which I love, and I'm going to do the heights first. So I'm going to press stat and I'm going to press edit and I'm going to enter my data. So I'm going to do the heights. So let's see what my data is for the heights. I have 72, 74, 68, 76, 74, 69, 72, 79, 70. Let's see, 69, 77, and 73. And it looks like I have 12 data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have my data entered for the heights, and then I'm going to press stat again. I'm going to make sure I move over to calc, and then I'm going to hit one var stats, and I'm going to hit enter. And that's going to give me my mean and my standard deviation right away. So my mean here is 72.75. Now, remember, your calculator does not distinguish between X bar and mu, so you just have to recognize that it's going to be the same value. So there's my mean. Now, for my standard deviation, it is a population data. So on your calculator, they use SX for the sample standard deviation and sigma X for the population standard deviation. So the one that I'm going to choose is this one, and it's 3.29456. I'm just going to write a few decimal places for now, so I have them. Okay. Now, we're going to end up rounding here. So what your book is going to have you use is about 72.8 and then about 3.3. So again, we tend to use one decimal place extra than the data set. Our formula is the sigma over mu and then multiply by 100 to get a percent. So I'm going to take that 3.3 divided by 72.8 and then multiply that by 100. And when I do that and I round, I do get about 4.5%. So 3.3 divided by 72.8, 0.3. Okay, and then multiply that by 100, and I get about 4.5%. So watch your calculator. I do the same things all the time that you guys do. I wrote 0.5 by accident at first, so just be careful because those little mistakes can add up. Now I'm going to do the same thing for the weights. So I'm going to go back to my data. I'm going to stick with list 1. If I highlight the list up top and I hit clear, don't hit delete, hit clear, and then hit enter, it will clear that list for me and I can start over fresh. So now I'm going to do my weights. 180, 168, 225, 201, 189, 172, 192, 197, 162, 174, 171, 185, 210. And I'm going to follow that same process. I'm going to hit stat, I'm going to hit calc and 1 var stats, and I'm going to hit edit. And I have my weights. So my mean weight is about 187.8. I'll just use 1 decimal place here. And again, don't forget we have population, so I'm going to use the sigma x. So it's about 17.7. Again, if I round to 1 decimal place. So my formula says I take that 17.7, I divide it by 187.8, multiply that by 100, and what you're going to get is about 9.4%. So clearly 9.4% is bigger than 4.5%. So this data set, the weights, are more variable than the heights. So because the percent is larger here, we have more spread in data. So there's more variety, more diversity, right? They're not as close around that mean. Whereas for the heights, our percent was only 4.5%. So the larger your percent, the more variable your data is.